Take 3. I think it's going to work this time, people. Lab 16. Radioactive Decay. So, here's the link that you want to click and open up. It takes a minute. I have it opened up right here. We are going to try to get pictures and years, numbers, of how C14, so C14 is radioactive, it's called the parent, N14 is stable, it's called the daughter. What does that really mean? We need to visualize it. So first thing, if you can't see this entire screen when you open it up, you may need to zoom out just a little bit. I had to do that to get the whole thing to fit. But you're going to need this pause button and the going by steps button. Okay, so I'm going to pause it and add a bunch of atoms. So you got to fill in all the atoms, that bucket of atoms. C14, they're red because they're radioactive. So this is the starting point, okay? And what we're going to do is go back and forth, and you have to get some data. So we want to see what is the ratio that's comparing two numbers. We want to see the percentages, the years, and we just want an overall picture of, is there a lot of red atoms or not? So ratio, to get the ratio, you'll take a screenshot. I hope it lets me do a screenshot while I'm recording. Maybe. Okay. So ratio is just comparing two numbers. And I realize that I need to do the first step before I do that, so don't make that mistake. So if I do the first step, it looks like my computer was a little slow. Let's try this again. Hit the step button. All right, that did it. So I hit the step button once. This is my ratio right here, 99 to 0. I've got all radioactive, and this is a super confusing concept. So hopefully it makes sense when we're done with this, but if it doesn't, we go over it more. So that screenshot right there, that's my ratio. I've got 99 radioactive elements, and I have 0 stable elements. That's the ratio. How does that look as a percentage? Okay, there's my percentage. So I'm going to take a lot of screenshots. You're going to take a lot of screenshots. This is already done for us on our lab that you're given. So this first one, you have the answers already, and you can see where did they come from. Okay, so my percentage, you can see this pi right here is 100% radioactive. Sounds delicious. Years, how many years has gone by? No years, we just started, okay? So there's 0 years that have gone by so far. That one, I'm just going to go with a 0. And then I need the atom visual. So the atom visual is just, what do I see here? Okay, and I'm going to take another screenshot. And basically we're just comparing, like, how does this material look? So this would be like if we're analyzing a fossil or something. The atoms, to get that visual, do I see mostly red, radioactive stuff, or do I see mostly blue, stable stuff? And so what we're going to do is we're going to stop this at 1 half-life, 2 half-lives, and 3 half-lives. But what does that mean? What is a half-life? Okay? So if I go step, 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 and I just keep stepping, you can start to see, it's easier if you do the step instead of play, because this goes way too fast. If I just keep clicking this step, I'm trying to get to the point where half of the radioactive stuff is gone. Okay? And there's different things I could pay attention to that. Now obviously this is going to be 1 half-life. It's already marked for us. So I'm trying to get to where half of the red is gone and turned into blue. Half of the C14 is turned into the N14, which is radioactive to stable, parent to daughter. So what does that look like for us? We just keep going, we keep going, keep going. That's as close as I can get to perfect. You see how we are right at that half-life, and I've got this stuff perfect. So now I'm going to take some more screenshots. My ratio is now 50 to 49, which is as close as we can get to. Half and half. So half of the radioactive stuff is now gone. You can see how the ratio changed. 99 to 0, 50 to 49. Basically a ratio of 1 to 1. Okay? What's my percentage? This graph, or the pie chart, whatever you want to call it, shows us that. So I'm going to take a little screenshot, and you can see how that pie is now half. It's not gone, but it's half changed. So now this pie is half radioactive and half stable. How many years has gone by? Well, for right now, it's really hard to tell how many years has this taken. If we were going to estimate, it looks like, 5,000, 10,000, maybe I'm around 6,000. It sort of looks like. I happen to know that the half-life of C14 is 5,700 years have gone by. Okay, and then what's the visual? It's just the overall, roughly, well not roughly, almost exactly, half of the radioactive is turned into stable, so it's half red, half blue. And so you can see how our visual changes over time. Okay? You need to go until another half-life has gone by. So what does that take? We're just going to keep hitting step, 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 step. And what I'm looking for is right here, this is red. Half of this red to be gone. So half of the red will be gone. I keep going. should be about two 5,700 year chunks of time. So each half-life is how long does it take for half of it to be gone. And you can see that now half of what we had, we've got half of a half. And then the next half-life will be half of that is gone too. Okay? So you take your pictures of this and you put them into this right here so we can track the changes. We're just trying to track changes as it goes from one half-life to two half-lives to three half-lives. Okay? And then you're going to do the same exact thing for U-238, uranium-238 to lead-206. So you will switch this over to here and you'll go through all those steps again. You dump out your bucket of atoms. Okay? And you'll go step by step and you can see how the U-238 changes. Basically all of the percentages and everything will change the same exact way. It's just how much time does it take is the thing that changes. So you can see that we're in billions of years here for uranium. So both of these things are the radioactive elements that we use to figure out how old things are. So that's day one's assignment. Day two, which if you're starting off with the lab today, we will get to during lab period, is going to be the decay rate. Day three will be measurement, and then day 4 and 5 we're going to do this radioactive dating game. Okay? So that is it. Ask questions, and see you tomorrow. Woo! Uranium-238 rocks!